Look at this continuous dependency loop. If you want to build software, you have to write it on existing hardware. But for that hardware to actually do anything, it requires software to tell it what to do. Think about this smartphone in your pocket. Without its operating system, that sleek piece of glass and metal is entirely useless. It's a brick. The physical components and the digital instructions rely on each other completely, which presents an obvious historical riddle. If a computer needs code to boot up, and code needs a computer to run, how did the very first machine successfully turn on before any code existed? To answer that, we must strip away every operating system and line of code and travel back to 1945 to see how computing started. What we find there forces us to completely rethink what the word programming actually means. In 1945, the ENIAC became operational as the world's first widely accepted electronic general-purpose computer, taking up the scale of an entire room. But inside this massive structure, there was absolutely zero software. It had no internal memory. To write code, operators spent days physically building instructions by plugging thick cables into central panels, routing the logic by hand. Beyond the cables, operators meticulously set large banks of manual switches and rotated mechanical function tables to dial in the exact operations they needed. Early programming was literal hardware reconfiguration. The machine and the code were the exact same thing. Hardware existed and functioned perfectly well before digital software was ever conceptualized. The blueprint for modern software actually existed at this exact same time. In 1945, a mathematician named John von Neumann published the EDVAC report, which outlined the concept of stored memory, the idea of keeping digital instructions inside the machine itself.